Okay, hi everyone. So I'm Utkarsh Gupta, and this is my screencast for the Codeforces Round 699. So it's going to begin in 2 minutes and 30 seconds. Yeah. So then I wanted to talk about a few things. Basically, first of all, join my Discord server. If you want to connect to me, the link is in the description. Apart from that, I make some content on an academy that you can watch for free. So currently I'm doing a course on maths in competitive programming. So it's all about the different type of maths concept that I used in competitive programming. Right now I've done a course on modular arithmetic and a lecture on modular arithmetic and one on this basic combinatorics. In the future I'm doing a lot of other things like sieve of Eratosthenes, some difficult combinatoric problems, and a lot of number theory things like Mobius inversion, etc. So yeah, we'll move from beginner to advanced. So you can check that out. The link is in the description. And apart from that, a lot of people were saying that okay, so not a lot, but a few people were saying that they don't get to hear my keyboard on the screencast. So basically, that's because I use a mic that does not pick up much of the noise from the surroundings. And on top of that, I have a noise filter which actually removes everything. So that's why you cannot hear the keyboard. But in this stream, in this screencast, I managed to fix that in some way. So you will be able to hear my keyboard this time. Yeah. So let me know what you think about it. And I don't think it will interrupt us in any way because like I either speak or type. So yeah. Anyway, um, so let's wait for this contest to begin now. And yeah, so I don't really have any puppy or kitten today because like that poll was very inconclusive, I would say. Like I mean, I should have added a third category, which should have been you choose. And although the first option won, I don't really know. I don't really know if I should go with it because in the polls, a lot of people who answer are um, not even my regular viewers. So like a lot of those are just puppy lovers and not my regular viewers, the people who voted. So that's the result of the poll is definitely biased. So I don't know what to do with that. So today I have nothing. And as far as the unique selling point is concerned, I'll think of something. Okay, so yeah, there will be something in this. I'll think of it in between the contest. But like I don't have anything ready right now. I don't know. Like I don't want to sing again. Obviously, I didn't want to sing the first time. I can maybe I don't know. I can. Can I give relationship advice? Like I'm probably really bad at it, but I can try. I think I'm not sure. Anyway, you were dreaming that you were traveling to a planet named Planet Forces on your personal spaceship. Unfortunately, its piloting system was corrected. Okay, Planet Forces. That's a strange name, but anyway. So space can be represented as an XY plane. Okay. Okay, so we want to get from here to there. And okay. Okay. You can delete some of the orders, but you can't change their positions. Can you delete several orders in such a way that you'll reach planet forces after the system processes all orders? Okay, so I think yeah, so I think we want to get the okay. I think I get this one. It is something like we are at this point and we want to get till this point, right? So basically, wait a minute. What are the constraints? Yeah, okay. So depending upon whether PXPY is positive or negative or something like that, we want to get till here. So like this length is X and this is Y. We want X right and Y up or something like this. or if it is here somewhere, then we want x left and y up, and at least that, because apart from this, everything else we will delete. I think that's all we want. Yeah. Okay. So first of all, we have test cases. I think here I will just store the frequency of all the 4 characters, U, D, L, and R. Okay, so I'll just make a frequency array. Okay, of size 250 is enough because we are just considering the ASCII values. So let me just clear this one. This will make everything 0. Okay, so now what do I have? The px and py. So I'll just call it x and y. Okay, and then you have the string. Okay. Okay. Okay, then we want the frequency of everything, right? Frequency of that, we just have to print yes, no, right? Okay. Frequency of that character increases by 1. Okay, now okay, so if x is we need to know the quadrant in which we are, right? So if x is greater or equal to 0, right, and y is also greater or equal to 0, this is one case. Other case could be if only x is greater or equal to 0. Okay, so this automatically means that y is smaller than 0. Otherwise, only y can be greater or equal to 0. And finally, both are negative. Okay, so here we are in the first quadrant. Okay, so if our frequency of wait a minute, x plus 1 means right. So if the frequency of right is greater or equal to this okay, so if the frequency of right is greater or equal to x, and the frequency of wait a minute, y plus 1, what it is, up. Okay, and the frequency of this u is greater or equal to y, right, then we can do it. So I'll just say answer is 0. If we come here, I'll say answer equal to 1. That means it is true. So this is like a flag. Okay, and that's what we want everywhere basically. So just copy paste this here. Okay, now okay, so if y is negative, we want this frequency of down to be greater or equal to the absolute value of y. If this thing is there, then I want the frequency of left to be greater or equal to the absolute value of x. I could write just minus x, but that's the same thing. And if this is L and D, then this should be absolute of x, and this should be the absolute of y. Okay, yeah, that's it. And I think that's it. So if the answer is yes, then we print yes. Okay, otherwise we can print no. Okay. Okay, 1000 submissions. And okay, so pretest passed anyway. Okay, 18 submissions for this one. Now after reaching a destination, we want to build, oh wow, so it is a continuous story. Okay, so we went to the planet forces. Now we'll make a new colony or something. Okay, we want to build a new colony on the planet, and it has many mountains, and the colony must be built on a flat surface. So you decided to flatten the mountains using boulders. You are still dreaming, so this makes sense to you. Were we dreaming? Oh, this is bad. I don't want to be dreaming. Oh, we were dreaming. Oh my god. So this entire contest story is a dream. Anyway, so you are given an array of size n. Hi is the height of highest mountain. K is the number of boulders you have. So you will start throwing the boulders on the top of the mountain one by one, and they will roll as follows. How about the first mountain? Okay. So if this is greater, then it will roll to the next mountain. If it is smaller, then if it is greater or equal, then it will roll. Otherwise, it will stop, and it will increase the mountain height. Okay. And if it reaches the last mountain, it will fall and waste collection system and disappear. Okay. You want to find the position of kth boulder, determine that it will fall into the waste. Okay, so there are a lot of boulders, and you want to find where the kth boulder will go. Okay, so I think it is something like wait a minute. I guess it's something like we have something like this, right? Histogram. Yeah, something like this. When we put the boulders, they will fill these spaces. Okay. Okay, now first it will fill this, then it will fill this and this, then this. Okay, after that everything will fall, right? Because if I put a boulder here, it will go till here and everything will fall. Okay, so yeah, so I think we can keep on counting when we will get when which will get filled, something like this. Like first this will fill, then this and this. Then let's say if we had something like this here, then these will fill, then these. Sorry, like this was filled first. I think this is just like we can do it with a monotonous stack, I think. So it's like when we have this greater one, we can merge these two, and the cost will be adding one boulder here. So in this way, our monotonous stack will always be decreasing. I think we can do this. There might be some easier way as well, because n is small. So there might be some easier way, but I'm doing it with monotonous stack. Okay. This almost sounds like an interview problem. The constants are too small, by the way. Anyway, I think after everything becomes equal, everything will fall, right? So maybe you can just count one by one and see where it will go, because you cannot have more than 100,000. Okay, so this is the easier solution. You cannot have more than 100 into 100 boulders that will get to the correct place, right? So yes, so yes, you can one by one simulate what will happen. I'm gonna do that only. Maybe I'll discuss the stack solution at the end. It would have worked if n was like till 10 to power 5 or something. It was a linear time solution anyway. So it's not required here. We can just simulate it in O of n into h or whatever time it is. Okay. We have n and k. We input both of them. Okay. By the way, how do you guys like my keyboard sounds? Let me know in the comments. Am I even audible over them? Okay, so what I can do is to print the number, right? So maybe I can just right. So something like while k is greater than 0, I can keep doing this. I have another boulder. Because I'll put this boulder, right? I can just do k minus minus. Okay. And now I have to see in which it will get stuck. Okay, maybe I can have a one indexed array. That will be better. Okay, so I start from the first one, right? From 1 till n plus 1, I think. Okay, and okay, so maybe it will be better if I take a variable I outside this. Okay, and something like while I is smaller than smaller equal to n. Yeah, I can do this. N plus plus. Okay, yeah, and here I have to see in which it will get stuck. Okay, it is something like if hi is smaller than hi plus 1, I can say here it will get stuck, so I'll say hi plus plus, and I can break it from here. Then finally when I'm here, if I is smaller equal to n, then we can say got stuck at I, otherwise it fell. Okay, so if this one fell, then all the future blocks will also fall, so we can just print -1, right, and we can return. And if this got stuck here, then what we can do is we can say if k equals 0, right, then we can say yeah, so then we can say I is our answer. I think that's correct. Okay, seems a bit wrong. Wait a minute. Okay, sorry. Okay, yeah, so we should put h of n plus 1 equal to -1. Okay, so basically like it should not stop at the last one. So the one that is after the last one is very small, something like this. Okay, I think this should be correct. So this is a easier solution that I wrote so that people can understand it, and I didn't write the stack solution because it's not required. But that one would have worked even for like there was a solution using stacks that would have worked in linear time. So even if it was like around 10 to power 6 or something, then also it would have worked. So I'll discuss that at the end. If you're interested, you can stay back and watch. Anyway, so you finally woke up after this crazy dream and decided to walk around to clear your head. Okay, nice. So the dream is over. Okay. And the fence is boring, so you repainted it. Wow. This reminds me of that story by Tom Sawyer. Sorry, Mark Twain. Adventures of Tom Sawyer, that novel. In that there was he was given it's called Work is Fun. The story is called Work is Fun. So he was given, I think, he was asked to paint a fence or something. Anyway, so you have a fence of n planks, and basically in that story he was asked to paint a fence, and he didn't want to do it because he was a very naughty child, and he used to disturb his aunt and irritate her. So she gave him the punishment to paint the fence, and then what he started doing is he started pretending that it's fun. So his friends came to him and started asking him to please let them paint it. So very reluctantly, he allowed them to do it, and then all the kids from the neighborhood painted the fence and did his work for him. So that was the story. Okay, anyway, 12 submissions on C, and and then I don't think that's the case here. So we have to paint it on our own. You have a fence of n planks where ith plank has color AI. You have to repaint the fence in such a way that ith plank has the color BI. Okay, they don't even want to have us like the same color for the whole fence. Yeah, maybe it makes sense. What do I know? So you invited M painters for this purpose. Is this actually the Work is Fun story? Because maybe it could be M children from the neighborhood. Um, The jth painter will arrive at the moment J and will recolor exactly one plank to color CJ. For each painter, you can choose which plank to recolor, but you can't turn them down. Okay, so each painter has to color exactly one plank. Can you get coloring B if you want? If it's possible, print for each painter which plank he must paint. Okay. Okay. So first of all, it depends on. We have the initial colors and we have the desired colors, right? We can leave some of the planks unpainted, and yeah, okay. So we can leave some of the planks unpainted, obviously, and we have to we have to necessarily use the last color somewhere. Okay, so the last color should definitely be in the new coloring. It has to be there, and maybe we can count for each color how many times it is required, depending upon whether bi is not equal to ai. Okay, so it is something like this. So, like you have the initial fence, right? Something like this, and they have some colors. Okay, so they can have some colors. Okay, and then there is some new coloring, and in the new coloring some are same and some are different. Okay, so you have to get these different, get these different, get these get these different, and this can remain the same, right? So, and you can paint over them. So if you had one guy who wanted to if you had two guys who wanted to paint red, so like if there was another color, like let's say if there was purple here, right? So if one guy wanted to paint purple, and that's not an issue, we can paint it on something and then the new guy can come and paint upon it. But if the last guy has purple, and that will be a problem, so the last color should be required at least once. And regarding everything else, we just have to see the number of colors that have to be changed, right? So we want two blues and one black, something like this. Okay, I think that's it. Okay, so this one is easy. So first of all, we have test cases, and then okay, okay. Okay, so for each color, we can have a required vector. Okay, so this will store how many times a certain color is required. Okay, we also need the arrays A, B, and C, obviously. I think this is fine. Okay. Okay, so first we take AI as input, then we take BI as input. Okay. So here we can do something like if they are not equal. That means the color BI is required once more. And yeah, so we have a required, we also need a has. Okay, available. Okay, so I'll be storing the available as well. For that, I think I need M. Okay, I think that is fine. And let's say the answer is 1. That means the answer is yes. Because we have to print the ordering as well. Okay. Yeah. Okay, so that makes it a bit tricky. Mm, hmm. Okay, so for now, let's just do it for yes and no. After that, we'll see how we can print the ordering. Anyway, so let's say the answer is yes, and then we can go over all the colors, right? And these colors, something like if the available of I is smaller than the required of I, then we can just say the answer is no, right? And return. We don't need this flag, I think. Okay. After that, we also have to check that this last color has to be required, right? CM minus 1. Okay. So if the required of CM minus 1, if this is 0, then also the answer is no. Okay. Okay. So now if you hear this, means that the answer is definitely yes. But we don't know how to print the answer right now, but we'll figure it out. Let's check if this was correct. Okay, so we have 3 no's, 1 yes and 2 no's. I think this is wrong. Okay, yeah, this is wrong. So what did we do wrong? What was this? 1 1. Okay, well, 1 1 1. Right? I think required was totally 0. Oh, okay, I get it. We can have something like max required. Okay, so this one stores unnecessaries also, right? And even if they are equal, we can say that the max requirement of BI is still increasing. Oh, sorry, yeah, and then we want to compare this one with the max requirement. I think now it is correct. So we have 2 no's and everything else is yes. Okay. Now we just need to assign a permutation to this, right? Okay, no, not a permutation. Like we have to tell them which blanket has to paint. He has to paint, right? So apart from just having this required, we also need the indices where it is required, right? So yeah, we can keep it as a vector of vector actually, vector of vector IDs. Okay, n plus 1. Okay, and here I can say the IDs of BI, right? And this in this I'll push back I. Okay, so I know I need I here. Okay, so I need one more thing. I need to know where I'll put the last one, right? I need to know where I'll put the last one, and I also need to know one more thing. Yeah, I think I just need to know where I will put the last one, and then uh, if I can store where I'll put the last one, all the wrong colors I'll put there only, right? So whatever is wrong I'll put there, right? So whatever is wrong I will put it on the last of the m minus 1, I think. Yeah, so this means that Wait a minute. Okay. In general, if okay, yeah, if the IDs of CM minus 1 is empty, then we can say wrong equals, also I need an int wrong. Okay. We can say if this is empty, then I will just put it in the last of CM minus 1. Okay. Otherwise, I'll put everything in the correct one. Basically, C IDs of CM minus 1, 0. So this will be the last fence that we will paint with the color of CM minus 1. Yeah. So all the ones that all the things that all the painters that are not required, we will ask him to paint on the wrong on this variable. Okay. I think it's fine now. Now we can just iterate on the array C. Okay. And the color here is basically CI. Okay. Now we will get the fence y equals, I think, IDs. Okay, maybe it is empty. Okay, if IDs y, sorry, IDs x is empty. So if it is empty, uh, then I'll just paint wrong. Okay, so we're just painting the wrong fence here. Otherwise, we can paint a correct fence. We can paint IDs x dot back. This is space, by the way. Right? And then we can just here only we can pop it back. Okay, I think this should be correct. Okay, oh sorry, I was supposed to leave a line, right? In the second one, they said the answer is 2 2, but I said it is 3 3, so that's the same thing. Then in the third one, what is the third test case, by the way? I think it is this. In the third test case, they said the answer is 1 1 1, right? And I said the answer is 3 3 3, so again it's the same thing. It's fine. In the fourth one, they said it is 21959, so that is correct. Okay, so I think it is correct. And obviously, if there are multiple answers, we can print any. Yeah, I think this was unnecessarily tough implementation. Maybe just a yes or no answer should have been sufficient. Like they could have asked just to print yes or no. And obviously, if somebody knows the correct answer, yes or no, then he can do this as well. They unnecessarily made us do it. But anyway, so there must be 500 submissions, I think. Just 272. Wow. Very less than what I expected. Maybe people are getting stuck with the implementation. So if they hadn't asked us to do this part, basically printing the actual solution, then people would have done it. But anyway, we're at problem D now, and D and E both have almost same number of solutions. But anyway, your friend Salim is rather and only loves math and geometry problems. Is this a geometry problem? Oh my god. Okay. He has solved plenty of such problems, but according to wow, how should I pronounce this? Varare. Let me Google this one. Okay. pronunciation. Let's see. Wow, it's not even a real word, I think. Maybe it is in some language. What? Why do we have this? Why do we have so many code forces results? This is ah. Mm, what? Andrew Lawrence. Why do we have Eknerwala's blog here? Wow. Okay. Anyway, so yeah, that is a useless story. Let's skip it. You are given a complete directed graph. What is a complete directed graph? I'm not sure. Mhm. Complete directed graph or simple directed graph where each pair of vertices is joined by a symmetric pair of directed arrows. Is this a complete directed graph? No, it is just a directed graph, right? Okay, so complete directed graph has all edges in all directions and then all self loops as well. Okay, the size is also small, I guess. Okay, in other words, you have n vertices and you have both directed edges. Okay, so this does not have the self loop. Okay, in complete directed graph there are self loops also, but here we don't have those. Okay, every directed graph is labeled with a character either A or B. Okay, is this like a automaton or something? You are also given an integer m. You should find a path of length m such that the string obtained by writing out edges labels when going along the path is a palindrome. Okay. The length of the path is the number of edges in it, and again within the same vertex and the same directed edge as any number of times. Is, I feel like this is an automaton or something. So it is something like you see, something like no, it's not an automaton. Yeah, it's not. We have a lot of vertices, and then from each vertex to some other vertex we can go. I think. Yeah, exactly. So we can do any of these. And all these have some labels. Maybe this can have A, this can have A, this can have B, this can have A. And then we have something like this from each vertex. So from here also we can go anywhere. Right? And this also has some labels like this can have B, this can have A, this can have A, this can have B, and so on. So we have from everywhere. And we want a palindrome string of length m, I think. Yeah. We want a palindrome string of length m. Okay, so like we start from here somewhere. We travel m edges, I think. M edges are. Wait a minute, what? Mhm. Okay, m edges, right, right. M edges. Yeah, we want m plus 1 in vertices, so obviously m edges. We want a string of length m formed by this, possibly something like this: A B A B B A B A, something like this maybe. And this should be palindrome. So okay, so do we have to make any such string or count the number of such strings or what? Okay, yeah, so we have to just print any such string. Okay, so we have to print one string that is palindrome, and That's it. Okay. Yeah, so I think the first observation here is that if we have two vertices such that this is A and this is also A, then it is very easy to do it. Like we can just keep on rotating in this, and no matter what the length is, it will definitely be palindrome because it will only have A, and so on. So this is just too easy. If we have A in one direction and then A also in the other direction, so maybe we can say that the graph will always be like this, because like this is the trivial case that we have already solved. So we can always say that whenever there is a graph from like whenever there is a edge with label A, the reverse edge will have label B. Something like this, I think we can always say, right? So now what do we want exactly? Okay, okay. Let me think this through. If we have a string of length m, like this should be equal to this, and this should be equal to this should be equal to this, and so on. Okay, also if we only consider the edges with label A or label B, then this graph won't have any strongly connected components, because if it had one, we would just keep on rotating in this, which would make it just too easy. But this is a complete graph, right? Okay. If we go from here to anywhere, is the answer almost always yes? Sometimes it is no. Maybe it is no in just very obvious cases, like maybe here it is impossible to have yes. Maybe for n greater than 3 or 4 or something, it is always yes, maybe. Not sure about that, but it seems like it. Okay. If we only consider labels of one type, let's say if I only consider A's, then I think I have a directed acyclic graph. Yeah. Yes. And there must be at least one path of length 2. Is that right? Can we have a graph in such a way that there is no path of length 2? If we have 3 vertices, and as I said, it is complete, so at least somewhere we will have this, right? And then the complementary graph will definitely be like this and this. So what about this edge? Yeah, so it is either this or this. So definitely we will have a path of length 2. Either this will be this or this. Okay? So we at least have a path of length 2. That's something that we know. So path of length 2 is available. Sorry, like this. Then I'm not sure if it will even help or not, but maybe we can have two A's like this, right? And then we can have two B's. Then again two A's, two B's, two A, two B, two A, two B, two A, two B. And we can keep on doing this. And we can also keep on doing 1A, 1B, 1A, 1B. Something like this. A, B, A, B, A, B. Right? Okay. So, yeah. So what if the length is odd? What will we do when the length is odd? I think we can get one string of three. I think we can do it easily for three. We can go like A, B, then again A. Yeah, for three it will work. Okay, so for three it will work with a single edge because we have like A and here we have B. So we can go like A, B, A, right? And if it is 5, then also we can go like A, B, A, B, A. And if it is 7, then also this is palindrome. If it is 9, then also it is palindrome and so on. Okay, so for odd M, it is always possible. Like no matter how it is always possible. You can do it using just two vertices. And you have one vertex, by the way. Oh, sorry. Yeah, N is 2, so obviously for M odd, we can always do it. The problem is for when M is even, right? Yeah, so when M is even, then there is some problem. First of all, we have two observations till now, that all edges are like this. In one direction they are A, and in the other direction they are B, and M is even. Okay, so if M is even, what should we do? Maybe it's something like I keep on doing A B A B A B A B, right? And then this is a string of even length, right? Okay, I think I got the answer, right? So when M is odd, this will be our answer. Like it doesn't matter how much this length is. Whatever M is, the answer will look something like this. And if M is even, then maybe if I make this B 2 times. Wait a minute, will B always be at the center? Well, sometimes B will be at the center, sometimes A will be at the center. But I think that will be fine. What I will do is I will put two B's here, and again this will become palindrome. And if it is something like this, I will put two A's here and will become palindrome. Okay. Maybe if we have a path of length 2. Wow, it's funny how everything I thought of has become helpful to us. Like if this is A and this is also A, we will definitely have a path like this of length 2, because as I said, if there are three vertices, right? So if something is like this, which it will obviously be, then either we will have a path of length 2 like this or like this. We will definitely have a path of length 2 if there are at least three vertices. And then we can keep on doing AB, 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 AB like this, right? And then we can do A 2 times. Then again we can keep on doing AB, 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 AB. This is this case. And if we want to make a string like this with two B's, so then maybe we can start here, right? We can keep on doing A, B, A, B, A, B, A, B, A, B. Then we can do B twice, and then again we can go A, B, A, B, A, B, A, B. And then that gives us a palindrome string. Yeah, so I think that's it. And we just need to know whether we want this type or this type, right? And we need a path of length 2. So yeah, I think that will work. So yeah, we can figure something out. Okay, so the test cases again. Okay, what is it? Okay. Now, as I said, if two opposite are equal, then we can always do it. Okay, so we can go something like okay. So now if Sij equals Sji, we can just keep on printing I and j alternately because they have the same letter. And yeah, we can just leave a line after this. We have one path like this. So now when we're here, we can assume that it is either A or B, right? Like in one direction it is A, so in the opposite direction it will be B. Now here, if M is odd, then also we have an answer. So we just have to print it here. So I think if M is odd, we can just keep on using one edge, right, up and down. So I think just 1 and 2 will work every time. K0 M, right? So we can just keep on printing A mod 2 plus 1, I think. Yeah, so this will alternately print 1 and 2. Yeah, this is also the correct answer. Okay. Finally, when we're here, the edges are like x to y we have A, and y to x we have B, right? And M is even. Yeah, something like this. I think the answer can be no if and only if n is odd. N is 2. Okay, the answer can be no if and only if n is 2. Okay, so if n is 2, then we have the answer that is no, right? Otherwise, we just need a path of length 2, right? So I think only the first 3 vertices will help us if we have these 3 vertices, right? So like 1, 2, 3 or something. Obviously, there will be at least one path that is something like this, and then we can use it to get our answer. So let me think. A, B, A. No, wait a minute. It is even, okay. A, B, B, A. A, B, B. Sorry, let me take another color. A, B, B, A. Okay. That is if you wanted to make it 4. Okay. And if you wanted to make it 8, then it would be like, no, wait a minute. If you wanted to make it 6 or something, what if you wanted to make it 6? Yeah. If you wanted to make it 6, then it would be like this, I think. A, B, this is 2, A, sorry. Okay, for 2, I think it is just AA, right? For 6, it is A, B, A, A, B, A. Okay, so for 2, 6, 10, etc., we have 2 A's. And for 4, 8, 12, etc., we will have 2 B's. Okay, something like this. Yeah, so first of all, let's find a path of length 2 by, I think we can just brute force all permutations of 1 to 3. So we just need 1 to 3, right? Okay, sorry, these were I plus 1 and j plus 1, by the way. Okay. Right. So permutation is 0, 1, 2. And we will go through all of these permutations. Go do while okay. Definitely in some permutation we will have a path from 0 to 1 to 2. Okay. So if right, so in some permutation we will definitely have a path of from x to y to z. Okay. So if right, so that means we have a path of length 2 with the same labels. So here we have found the answer. We can even print yes directly here. Okay. Yeah. And now we will use these 3 vertices to get our answer. Okay. Before returning, we can leave another line. Okay. We have to print the answer here. Okay. So it depends on m whether it is divisible by 4 or not. Okay. If m mod 4 equals 0, then we have some other condition. Otherwise, we have some other condition. If it is divisible by 4, then this means we need 2 b's. Here we need 2 a's. Actually, like I was assuming that these both are A, but it is not necessarily true. These both could be B as well. But yeah, so we don't care about that. Anyway, so let's see the two A's and two B's cases. First of all, let me get the correct labels. We know that we have a path from X to Y of A, and then we have from Y to Z of A, right? So in the two A's case, we will start from X. We'll keep on doing A, B, A, B, A, B, A, B, and then we will do A again, and then we will keep on doing A, B, A, B, A, B, A, B. What? If we wanted a path of length 2, then we do A. If we wanted a path of length 6, then we do A, B, A, A, B, A. Okay, so I think first we do something for this m by 2, and then we get here and do the same thing again for the next m by 2. This we do for 2, 6, 10, etc. Let me solve this case first. Okay. I think I did something a little wrong, and I think we have to print m plus 1 characters, right? Uh, yeah, exactly. We have to print m plus 1 characters. So I have to fix it everywhere. Okay, so I will have to fix it here as well because we need 2m plus 1 characters, right? Maybe we start from a, sorry, so let's see the sequence here. For 6, we have x, sorry, we have x, y, x, right? Then we again have a y, then z, x, y, x, sorry, x, y, x, then again y, then z, y, z. Yeah. Yeah, first we print x, y, x, then we print y, then we print z, y, z. Okay. So first of all, we print x. Right? After that, we print z, y, z. Okay. Yeah, this is correct, I think. Yeah, this will always work. And if we needed it for length 2, then we would do something like xy, then again then z, I think, right? Yeah. Yes, that will work. Okay, so we just have this case now. In this case, it is something like we want a string like a b b a, right? So we start from y this time, and then we do this a b b a. Okay, right. So what are we exactly printing? We're printing y z y. Okay, and then x y, I think. Okay. Mm, wait a minute. If we had a string of length 8, then what would we do? Right? 4, 4, 8. Okay. A, B, A, B, B, A, B, A. Okay. So we have Y, Z, Y, Z. Okay. Then again Y. Okay. Then again Y, Z. Sorry, Z, Y. Fine. So we made A, B, A, B. Yeah. Then we need B, A, B. Okay. So now we will do X, Y, X, Y, I think. B, A, B, A. Okay. So yeah, first we print y z y z, then we print x y x y, and in the between, in the middle, we print y. It is almost similar, just that first of all we print y z y z. Okay. Then we print y, and then we print x y x y. Okay. This is probably correct. After that, we print a new line and then exit. I think there's nothing that can go wrong here. Okay, so there's something that went wrong here. Why am I printing one every time? Oh, right. Okay. Yeah. Obviously. Hmm. Last one is no. That's fine. First is correct. Second correct. We're doing 2 1 2 1. So maybe from 1 to 2 we have the same character from 2 to 1. Yeah, we have BB. Okay, so that is fine. The third one we're doing 1 2 1 2 again. Again we have BB. And the fourth one we're doing 3 1 3 1. What? Okay, yeah. So we have, yeah. So samples are correct. We can submit. There must be, I don't know, 90 submissions by now. 90 correct. 111, and we did it wrong. Oh, wow. Okay. We did something wrong. Okay. Oh, right. Yeah, I forgot to do this. I remembered. I thought I would do this, but I forgot. So this is zero based index, and we wanted one based index. We just wanted this. Ah, unnecessary penalty. Anyway, so yeah, so we got wrong answer once because we forgot to add one everywhere. So I thought of adding one by one here, but I did this instead. I remember doing it here, but I remember doing it here as well, but I forgot it here. Okay, no worries. We got it right now. So we have 122 correct submissions. Let's see the standings at what rank we are. 150 or something. Mm, oh, sorry, show unofficial. We're at 150 something. Let me see the friends standing. We're at 93. Okay, that's pretty nice. And if we hadn't done the mistake that we did, the small mistake, then we would have been even better. But anyway, now we have this sorting books, I think. So we had this AB graph, then we also have this AB tree. That seems interesting. So this one actually seems tough to me because let's see the standings again. Okay. Okay, maybe it's not that tough because if you look at these people, they couldn't think of D, but they did E. But maybe they didn't want to do D because they already knew the solution. They're all out of competition. Yeah, we can't conclude anything like this. Let's try it. One thing I know for sure is F is actually really tough because otherwise, at least some LGM would have done it because you can see LGMs are also participating and other people are also very smart and they've been stuck at it for like, I don't know, 20 minutes or something. And they're not able to come up with any solution. Anyway, so one day you wanted to read something, so you went to your bookshelf to grab some book. But when you saw how messy the bookshelf was, you decided to clean it up first. There are N books standing in a row on the shelf. The ith book has color AI. Okay. I'd like to rearrange the books to make the shelf look beautiful. Shelf is considered beautiful if all books of the same color are next to each other. Okay. Okay. Oh wow. The statement is like it's so simplistic. Wow. So the statement is just something like maybe you have some maybe you have an array of numbers, something like this. And in one move, you can pick an element and put it to the end of the array. And that's what you want to do. And when you're done with this, you want all the values of the same color to be together. Something like this, I guess. And you want to print the minimum number of moves in which you can do this. Let's try to examine some cases like the one that I just wrote it here. One thing I can observe is unless 2 is already at the end of the array, or whichever element we're talking about, unless it is already at the end of the array, maybe we can just always, like whenever we push it to the end, we will push all of its occurrence to the end, because otherwise what is the point, right? Yeah, so we will definitely push both of the 2's to the end. So this might be an important observation later. And then if we push 3, you have to push all the 3's to the end. Or if we push 1, we have to push all the 1's to the end, right? So if we push 2, maybe we will just push 2, then push 2 again, these two operations. We have 2 2 here, and we remove this. And then if we either we have to fix the 3 or the 1, so both will cost us same, and the total cost will be 5. But if we don't remove the 2's, right, then I think we have to remove both 1 and 3, because otherwise we won't get these two together, right? So that will cost us 3 plus 3 6, something like this. Are there any constraints that will help us? Okay, I don't think so. Okay, so we don't have any helpful constraints, like we don't have any constraints that are helping us. Sometimes it is given like the total number of distinct books won't exceed something or anything like that, but we don't have anything like that. So this is a simplistic statement with full constraints. So it is something like if we don't remove 2 and we have the first occurrence of 2 and the second and the last occurrence of 2, right? Between that, okay, so like any number, if we have 2 and they can be in between as well. Like if we have the first and the last occurrence of 2, and if I say that I won't remove 2, what I will do is I will remove everything that comes in between, and all occurrences of everything that comes in between, right? From everywhere, something like that. That's what I will do, and I'll remove all of them. So basically, I'll add to my answer the frequency of all of those. Can we model the problem in such a way that this last one never bothers us? So right now there's a problem that if there was a 4 here and if we send it to the last, we don't have to get the both 4's to the last, because you know this one already like this is already contributing to the answer a little bit. I mean, sorry, yeah, this is already at the end, right? So if we keep it here and if we send it here, it costs us only 1. But anything else, if we send it to the end, it costs us the frequency of that character, of that thing. right? So what can we do? Can we just ignore the last one for the frequency? Yeah, I think that's what we can do. So like if we had a 4 here as well, we could say something like the frequency of 4 is just 1 instead of 2. And even if we have two 4s here, we could say the frequency of 4 is just 1 and not 3. I think that fixes that and it takes care of all the cases. And we'll still consider the first and last 4s like this, but the cost of 4, basically the cost, I'm saying cost because that is the cost of basically removing it, is just 1, right? So maybe that's what this problem is about. We just have to remove the characters. I mean, instead of sending it to the last, can't we think of it as just removing 2s from everywhere? And the cost of doing that operation is equal to 2. And the cost of removing all 3s is 3 and removing all 1s is 1, something like that. So we can think of it that way as well. So maybe when we start with 1, it is something like we will either remove 1, all the occurrences of 1, which will cost us something, let's say C1 in the cost of 1. Either we can do that, or else we can remove everything that is between the 1s, all of these numbers, right? Yeah, so maybe if we renumber them in such a way that, you know, like if we had something like 3 4 3 1 5 3 1 or something like this, maybe we can renumber them according to the first occurrence, like all the 3's become 1, then all the 4's become 2, then all the 1's become 3, maybe like this we can renumber them. And according to me, the advantage of this is when we are here, we either remove 1 or we remove everything in between, right? So since they are sorted according to the first occurrence, so what I can do is I can just say I reached this part of the array and now I have removed everything that is smaller or equal to 4, because like obviously 1 is also removed in a way that, in the sense that it's not there anymore, like it's not in this part of the array, and everything else will also be removed because it is in between 1. So obviously 2 3 and 4, everything is removed. And then that is the case if we remove 1, sorry, that is the case if we don't remove 1, okay? But if we remove 1, then everything will get removed like this, and now I can say that I'm here and I've removed everything that is smaller than 1. So that gives me a kind of a DP solution, maybe. Like I can store, when we remove 1, we remove everything that was smaller or equal to. So this gives us a way that whenever we have something like if we're in the between, if we're in the middle of the array, if we have 16 like this and a 16 like this, we will never have a 15 in between, right? Because either we have already removed 15 or we have removed all the 16s. So it is impossible to have something like this, to be at, like, to be considering 16 right now and to be at this point, like when you have this 15 in between. So in between, always you will have some bigger number like 17 or 18 or something like that. So yes, we have two options here. We can either remove this, remove all these 16, or we can remove everything that is in between, right? And since they are sorted by the first occurrence, then I think I can say that the greatest number before this, right? So before this, whatever the greatest number is, I think maybe till that we have to remove everything. Yeah, that works. Yeah, that will work. Yeah, I think that will give us a solution, a DP solution actually. So basically, when we are here, we can either add the cost of removing 17 and go here. Either we can do that. We can either add the cost of removing 16. So we can just do something like remove 16 and then go here, right? Or else we can remove all of these and go to 19, right? Yeah, that's exactly the DP solution. And whenever we go somewhere to any value, we always go to the first occurrence of that value. So for each value, we only need the first and the last occurrence, and we need to renumber this array as according to the first occurrences of everything. Yeah. Okay. So I think I have the solution now. We have to sort them according to the first occurrence, right? Hmm. Hmm. We need the first occurrence of everything. So maybe we can store it in a map. Okay. Now I have the first occurrence of all the numbers, and sort them according to that maybe. No, I think I need the opposite. What am I doing? So based on the first occurrence, maybe I need another thing, another map. Wait a minute. So I need to put the occurrences somewhere. All these first occurrences I'll put somewhere. Then I'll sort this vector obviously. Oh, it's already sorted. Okay. Maybe we can just give it an ID. Yeah, exactly. That's exactly what we want to do. And I can give this ID. Okay. Fine. So now all of them have a certain ID. And now I can replace it with their ID. Within this loop. Now I can even print this thing and see if it is working. 01102 0111. Okay, we can try that thing as well. 343151. Zero one zero two three 0102302. Okay, yeah, so that is working. Okay, and we don't need to remember the original input because we just have to print the number of operations. Okay, so we have this new modified array and we can print the answer here as well. Okay, so now we need the cost for everything, right? We can have something like cost of n, something like this. What if we started this from 1? That would also be fine, right? It is the same thing. Yeah, this is better. Okay. So now we need the cost for everything, right? Cost for everything could be something like maybe cost of AI plus plus. But for the last ones, we have to decrease it, right? We can go something like cost of a n minus 1 gets decreased by 1, right? And we can loop in a reverse order, start from n minus 2 till 0. Okay. Okay. If if ai equals ai plus 1, then we will do something, otherwise we will just break from here. Then I can again say cost of AI gets decreased. So for the last part, I decrease the cost. Yes, I think we can print the costs now. I'm printing all of these things so that the viewers can understand what I'm doing, and also so that I don't make mistakes regarding these things. So yeah, I think this one is a bit. Wait a minute. Why do we have 4 integers here? Why do we have 1 extra every time? Okay, sorry, this is still ID. Yeah, so the cost for this is 2, this is also 2, this is 0, then 1 and 2, then 3, 1, 1 and 1. Okay, sorry, 3, 1, 1 and 1. Okay, yeah, so I got the costs correctly, and maybe I will need the cost in a certain range, like, so I have this first 3 and this last 3, and I have to remove everything in between them, like 4 and 5. I need the cost in a range. For that, I have to use the prefix sum. I can do something like cost I plus equals cost of I minus 1. That's exactly why I started ID from 1 instead of 0, because otherwise prefix sum causes some problems. Okay. And yeah. Okay. So we did that. Now what do we want? So now we want the dynamic programming, the DP. Okay, so maybe we can have something like DP of n, right? And there's also one other thing that we need the last occurrence of everything. We need the last occurrence of all the values, and that is pretty easy. I think I can do it in just one loop. I need both first and the last occurrence. I need both first and last occurrence of everything. So last is actually pretty easy, I think. Okay. Okay, so now I have the first and last occurrence of everything. I think I can even print it. Hmm, 0 and 3, 1 and 2, 4, 4. 0 and 4, 1 and 2, okay. 0 and 5, yeah. 1 and 1, 3 and 6, okay. 4 and 4, okay. So this is fine. And I also need the minimum between the first and the last, okay. So to get the minimum between the first and the last, I need a sparse table, so I'll build that. Okay. This will give me the minimum in the range. So it takes vector. I'll make this a vector. Okay. I think everything is fine till now. Okay, so it took some time to build this sparse table, but everything else seems fine. I think maybe we can even print the maximum between the range. Okay, sorry, we need the maximum, right? What am I storing? I'm storing the minimum. Okay, we need the maximum. Yeah, we can even print the maximum in the range. To see if this is correct or not. So in between this, we have two. I think. Yeah, we're starting from 1. Okay, between ones we have 2 as the maximum. Between 2 also we have 2. Okay. Okay. Between the threes we have 4. Okay, 1, 2, 3, 4. Yeah. Here we have 2. Okay. So here we have 4 and 4. Okay. Yeah, everything's fine. The spice table also working correctly. Now we just need to use DP to get the answer. Yeah. So what are the two options that we have? So the two options are to remove I and go to I plus 1, or remove from I plus 1 to max and go to I plus max plus 1, something like this. Maybe we can just use a recursive DP, that will be a bit easier. Does that depend on what else we previously removed? It does not, because we remove everything. Okay. So I just need a function calci. We need the index. I'll just call it x or something. Okay. Now if x is greater than id, then we can just return 0. That is the base case. Otherwise, dp of x, if answer is not equal to -1, we can just return the answer. And in the end also we have to return the answer. You can say answer is infinite and you have to minimize it. Because one way to do it, one way to do it is just we take the cost of x plus the calci of x plus 1. One way to do is this, obviously. The other way is to first get the maximum in the range. The maximum is from the sparse table, we will get it. Right? And we have to remove everything in this range, right? Okay, so the remove cost will be equal to the cost of removing everything till max minus the cost of removing everything till x, right? And yeah, actually this is cost of x minus cost of x minus 1, and that's because this was the prefix sum, right? So we subtract the previous element to get the current element. This is the removing cost, and then we jump to max plus 1. Okay, so then we can say a min answer comma remove cost plus calci of mx plus 1. We basically jump till mx plus 1. I think that's it, and we just have to print calci 1, I think. We don't have to do anything else. Wow, okay, wow. Okay. Wow. How can this be negative if the costs are increasing? We're getting negative answers, right? Wow, okay. Well, maybe we can just print this. This has to be negative somewhere. Wow, this is always positive. How are we getting negative answer then? Maybe this is negative. Okay, yeah, so this is sometimes negative. How is this possible? It's a prefix sum of positive values. How can it ever be negative? Hmm. For 4, this is minus 4. Hmm. Don't even have a 4 here, right? Oh, sorry. If this is greater or equal to ID, then I think we have a problem. Yeah, I think everything is fine now. Obviously, for the non-existing element, it was negative. The cost was negative. So the answer here is 3 according to this. Is it 3 actually? Maybe we don't have to remove this and then we remove. Yeah, okay, so we remove 4, 1, and 5 and 3. I think this is correct and we can submit and try it. I went really slow with the implementation. I didn't want any wrong answer in this one, but it wasn't that tough. This is a simple DP. Maybe only this part was a bit tricky to come up with. Okay, wow. I think I made the verdicts too fast, so we got a wrong answer here. Maybe our logic was wrong, or just the implementation. Okay, so this is fine. What can be wrong here? So let's see what we did exactly. We sort, sorry, we give them ID. Okay. Then we forget this array and we consider this array. Mm, we start from 1, then either we go to 2 or we go to this 3, I think. No, to 5. And 5 is definitely greater than ID, so that is over there. Maybe we can, or we can go to 2. Okay, so when we go to 2, we have this as our range. So we can either remove this and go to 3, or we can not remove this and again go to 3. Obviously, it will be better to not remove this and go to 3, right? Then when we're at 3, we can either remove this and go to 5, which will definitely give us an answer. Maybe we can no, if we remove 3, we go to 4, and this 1 is already gone. I can assume it's gone. Basically, we can assume that whenever we write to some value, let's say 4, then all the values that are smaller than 4 that are either gone or non-conflicting. Okay. And what I mean by gone is that it has been removed, and what I mean by non-conflicting is that it is present to the left. Okay, so it is not on the right. When I have the first and the last occurrence of any number, and I take the max in that range, so it is at least that element, maybe even something bigger than that. So if it is something bigger than that, if it is that element itself, then we can move further for free. But if it is something else, then we remove everything from x plus 1 till that element. Right? So is our sparse table wrong? I don't think so. We have max log till 20. 2 to the power 20 is definitely greater than 5 into 10 to the power 5, so that is fine. What? This should be correct. I mean, I wrote it a long time ago. I don't think it's wrong. We reach till the end. That means you've done it, so we return 0. It's fine. Otherwise, the answer is dp of x, and if it is not 1, we return it. That's fine. That's how dp works. This is the cost of removing x, and we move to x plus 1. This is the max value. That is the first table query for x from first till last. Okay. Then we remove everything between first and x. If we are not removing x, so obviously we have to remove everything else in between. Then we can go to mx plus 1. Yes, obviously. So what is wrong here? Everything seems so, it seems very correct, I think. For each value, I have the first and the last occurrence. I have the sparse table on the array A. I print cal C1. Maybe I can start that from 0, but then this will cause some problem. Is cost 0 always 1? Yeah, it should be, because this is a global array. So fine. Even if it is not, then since this is a prefix sum, that's fine, because we're always subtracting that. Maybe there's another way to think of it. This seems so right. Whenever we have the first element, we either remove it or we remove everything that was between the two, between the first and the last occurrence of that. Right? So this is just too right to be wrong. Too right to be wrong. Mm-hmm. What? Mm-hmm. If something is only at the end, oh, oh, okay. I think I found the counter case. It's something wrong in the logic. It is something like one. If we have something like 1, 2, 3, right? Then we have 3, 3, 3. Wait a minute. 1, 2, 3. Okay. Then a lot of fives, and then another 3 and a 4. Okay. So in this case, the correct answer is to get this here. Sorry, get this here, and then get this here. And we didn't cover this one, right? So we should. What does this actually mean? What does this case mean? I'm not sure what this means, but it does seem to me something like we. What is it? How can we include this in our solution? Really, we take it to the end, right? And then we remove everything after the last occurrence. No, 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 that's not just that. Maybe we're doing something like, okay, first of all, this is 4, 4, 4, 4, 4. And then 3, and then 5. Okay. We take this here, okay. Maybe it is something like if we remove this 5 from the end. Oh my god, this is so bad. Gives us yeah, so this I think this totally destroys my solution, and maybe that's not how we can solve it. We don't have much time left. I'll try to include that in my solution because we cannot think of a new solution now. So what if we take this 3 till here, then sorry, we had a lot of 3s here, and we don't want to remove all 3s and we don't want to remove all 4s, but what we can do is we can remove all 5s. This is actually very complex because here what we're doing is we're removing till a certain, like if we had a lot of 3s, it is something like till a certain point we're removing all these 3s, and after that we're removing everything to the right of it. That actually makes it really tough because Then we have to take care of everything in between here as well. And then we remove all of this as well. Although to simplify it a little, it can be thought of as we just remove this 5, pay the cost 1, and continue solving the problem again. Like remove the last element, pay its cost, and solve the problem again. So we can keep on doing this. Like we want to solve the same problem that we solved, but we want to solve it only up till a certain index. And yeah, something like this. Up till a certain index, or maybe up till a certain value, then maybe we can decide to end at 4, right? But then yeah, that is something like this. Maybe we can decide to end at 4. Yeah, or it could be like maybe just ending at 3. Not keeping 3, maybe there could be a 3 in between here, right? So we have to remove both of them. But we're not removing this last block. And instead of removing that, we are removing everything to the right of the last block. It is just like, wait a minute, how much time is left? 4 minutes. Yeah, I don't think I can do this one. Mhm. Let me see the number of submissions anyway. 117. Wow. Okay. Uh, I don't know who these 117 people are. Like in my friend list, there's only Neil. Wow. So, okay. So, yeah. So, my solution to E was wrong and I was not able to do it. I'm wondering if I should keep this part in or crop it out. Like, maybe it can help a few people, but it's wrong. Not sure whether to keep it or not. Hmm. I don't even know the correct answer till now. And even if I knew it, I didn't have enough time to implement it. Oh. Actually, the problem that I found gives rise to different kind of problem as well. Maybe if we had a 3 in between somewhere like this. Hmm. And like all these were 5. This was 6. And this was a 6. So maybe we can remove these 2 threes and this 6. Oh, 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 oh. I think I got it a little bit. I think it's something like mm, mm, let me think. So maybe we are removing till a value, like till 4 we are removing everything. And then from the other side we're removing from a value. Like from 6 onwards we're removing everything and till 4 we are removing everything. And 3 is like the decider that till here you're doing one thing until here that you're doing another thing. Something like this. Maybe we can repeat from no we can't. We can't. Wait a minute. Mhm. Wow, actually there are some more problems here. And they are like if we try to do this with 3 once and then we try to do it with some other value as well, like we try to do it with 2 as well. Then I don't think we can do it with 2 because hmm, like, we can't do the same thing with 2 if we had 2 here sometime somewhere, I think. And can we do it? That we remove this everything from here. Actually, my first observation was wrong. My first observation was something like if we have a 2 somewhere and we have a lot of 3s or anything like that. If we put 1, 2 to the last, that means we will put all the 2s to the last. But that wasn't correct because we can put 1 or 2 2s to the last, and then we can put all the 3s to the like even right of it. So these 2s will get all together. That was wrong, and that's why our entire solution ended up being wrong. That is over now. Let's see the number of correct solutions. 125. Okay, 125 is not bad. Nobody in my friend list got it except Neil. Okay, so I'm just deciding to not uh, crop this part out. So if you guys want to see it, you can see it, but I'll write it in the description that it was wrong. Anyway, so thank you for watching.